Hi pre-calculus students, welcome to your first video notes for homework. I'm just going to run through the second two examples from class that we didn't get to so that can help you with your homework over the weekend. So it should be pretty quick. So the first problem, example 3, was a production line supervisor knows that 4 out of 100 whatnots manufactured during our particular shift are defective. If 8 whatnots are chosen at random, what is the probability that at least one of them is defective? So this one starts to feel a lot more complicated. The thing that's most complicated here is probably this idea of at least one of them is defective, meaning it could be 1, it could be 2, it could be 3, it could be 4. Or I'm sorry, they're choosing 8, so or 5 or 6 or 7 or 8. So there's a lot of different situations to try to count. The easier way of going about this is going to be to think about, well, at least one means all of the different cases except for none of them, right? None of them being defective. So why don't we consider the probability of none? As in, I choose 8 and none are defective, and then subtract that, do 1 minus the probability of none, and that should equal exactly the probability of at least 1. Because together, the none being defective and 1, 2, 3, 4, 5, 6, 7, or 8 being defective covers the entire sample space. So if I want to try to come up with a probability of none, well, I have to think about setting up a fraction where the numerator is all the different ways I could pick 8 and get none being defective. So I can actually count that using a combination. So if 4 are defective out of 100, that means that 96 aren't. So I'm wondering how many different ways are there, if given 96 non-defective ones, can I pick 8 of them? And order doesn't matter, so I'm doing a combination, not a permutation. So 96C8 should tell me the total number of ways there are for me to pick 8 non-defective ones. And then it should be out of the total number of ways there are for me to pick 8 whatnots. So that would be 100C8. Okay, so I could plug this into my calculator and get a value. And in fact, I did, and I got 0.713. So then the idea of the probability down here would be it should be exactly 1 minus 0.713, which is 0.2874. And in this case, it makes more sense for me to actually do out these combinations using my calculator because I'd rather have a decimal answer as my probability or a fraction so that I actually kind of have some idea what's the meaning of my answer. Okay. So looking at example 4, and before I actually move on, I just want to encourage you guys when you're trying out your homework, there might be ones you don't have to use a combination, but think about if you can, because a lot of times that's going to save you time. Okay, so for example 4, it says a bag contains 3 black, 5 green, and 4 yellow marbles. What is the probability a marble selected at random will not be yellow? Okay, so I could just add the black and green and do it out of the total, but I'm going to model the idea of it being not yellow as being 1 minus the probability of me drawing a yellow one. Just because I don't have to do it here because it's a pretty simple example, but I could. So the probability of yellow, well, there's 4 yellow marbles, and there's a total of 4 plus 5 plus 3, so 12 marbles. So that would be 1 minus 4 out of 12, which gives me 8 out of 12, which is 2/3. That one probably you could have done on your own. So now this part B is thinking about choosing 2 marbles at random. Both are black. What does this look like with replacement versus without replacement? So if it's with replacement, then it's not going to be a combination because combinations we're not replacing, or we don't have repetition. So then I just need to think about each case. Okay, so the idea is I'm choosing 2 marbles. So for my first marble, in order for it to be black, well, there are 3 black and there's 12 total marbles. So the probability of, I'm going to put it as BB for like drawing a black and then drawing a black again, would be 3 out of 12 is the probability of me drawing a black the first time. But then it's an and situation, right? So and I also want to draw a black the next time, but it's with replacement, so I drew a black and I threw it back in the bag. So there's still a 3 out of 12 shot for me to draw a black the second time. So that's with replacement. So then I would just multiply across and get 9 out of 144. Okay, without replacement, it's a little bit different. So one way of doing this is starting the same way and saying, okay, the first time I have 3 out of 12, but I drew a black, so now there's only 2 black remaining out of 11. You could do it that way, and you get 6 out of, I think it's 132. Is that right? Yes. Okay. Another way is to think about this as a combination. So it's this idea, the probability of both black should be, well, I'm choosing 2 marbles out of 3 black ones, and I'm to ensure that they're black, right? It would be 3 total black marbles, choosing 2 of them. So that's 3C2 divided by, well, what are all the ways there are for me to pick 2 marbles out of the total number of marbles? That would be 12C2. And if you do this out, you could either, crunch the formulas or plug this into your calculator. You should get the exact same fraction, and you do. And obviously this can be simplified. So I think this, yeah, 6 goes into 132, so this becomes 1/22. Okay, so you can kind of keep these principles in mind as you try out the problems on the back, and we'll definitely be discussing them in class, but I would encourage you to think about situations in which the total number of possible successes could be expressed as a combination, and that's going to help you out a lot, especially when you're thinking about some of the card problems. Actually, the card problems and the coin problems will be benefited by thinking about combinations. So we'll go over these in class. Have a wonderful weekend.